Have you ever stared at a bunch of entities and wondered even how to start connecting them so that you can have an ER diagram? In this video, I'll show you exactly how to start building relationships the right way step by step and clear up the confusion between different notations. We will start by providing an accurate definition for the ultimate goal of database design, a complete entity relationship diagram. So an entity relationship diagram, short for ER diagram, is a visual tool that's used to design databases. It shows how different pieces of information relate to each other. What information? Like entities, attributes, and relationships. Entities are the things you want to store information about, like customers, products, or orders. These appear as rectangular boxes in the diagram. Attributes have the specific details about each entity, like a customer's name, email, and phone number. Attributes are represented in the rectangular boxes of entities, as well as their corresponding data types. Relationships show how entities connect to each other, like customers place orders, or orders contain products. Relationships appear either as diamonds or lines connecting entities depending on which notation you are using. A complete ER diagram may look like this. Well, you can think of it as mapping out all the important pieces of information and connecting them. For example, in an online store's database, it would have customers who place orders, and those orders contain products. The ER diagram would show these connections visually before you actually build the database. The main benefit is that it helps you plan out your database structure clearly before you start building it, making sure that you don't forget important connections or information you need to store. That's everything about the definition of ER diagrams. Let's move to discuss the different types of notations. There are two very popular notations that are used to draw ER diagrams, including the Chen's notation and crossfoot notation. So Chen's notation has its origin in a paper published in 1976 by Dr. Chen, hence the name Chen's notation. It's widely used by database textbooks and taught across different higher education institutions across the world. For example, the textbook Database System Concepts adopts Chen's notation for all the ER diagrams used in this book. An example of an ER diagram developed using Chen's notation looks like this, on the right side of the screen. It comes from the book Database System Concepts. Some notable features of Chen's notation include representing all the relationships between entities using diamond boxes and using underlines to denote primary keys. In comparison, crossfoot notation has its root in a different paper published in the same year by Dr. Everest. Crossfoot notation is used more widely by the industry and practitioners, and it's also used by some database design books, like Grokking Relational Database Design. I'm one of the authors of the book. An example of ER diagram that uses crossfoot notation looks like this, and it comes from the book Grokking Relational Database Design. In this and all future videos of this series, we will stick to crossfoot notation, mostly for the consideration of practicality. I told many students using Chen's notation in the past, and the very valuable feedback that I got for many times is that the gap between using Chen's notation for coursework and using crossfoot notation during work is painful to conquer. Crossfoot notation does have some advantages in comparison, such as crossfoot notation is more visually clear and efficient, without the diamond box representing relationships, where the foreign key goes is more self-explanatory. Beyond that, most popular database design tools default to crossfoot, and crossfoot notation is widely used in business and consulting environments. Okay, that's everything about the notation types. Let's move to explore a bit about how you start connecting related entities. Imagine that you are working towards designing a database for an online store named the Sci-Fi Collective, and have identified all the entities, attributes, and the primary keys. Beyond the entities, attributes, you have also extracted a set of relationships from your requirement analysis. The next immediate task you will face is to connect the entities using lines based on the summarized relationships. This step doesn't involve attributes, at least not yet. So we can do something to simplify our representations of entities by hiding the attributes for now. So we only have 6 entities representing user, product, product review, purchase records of users, and payment methods. Additionally, we can make the relationship summary even more succinct. The nouns in every sentence represent entities. If 2 nouns connected by some verbs show up in one sentence, then the 2 entities are likely to be in a relationship. You may go through a few iterations of trial and error when mapping the summary to a diagram because of possible inaccuracies and misinterpretation. Based on the existing information, we can connect every 2 related entities like this. When you generate a draft diagram, you should test every relationship against the information you gathered and the sample data you collected. Also, take the draft diagram to the stakeholders and explain your design rationales to them, because it's likely that you made some mistakes or neglected something critical in your first iteration. For example, the software developers of the Sci-Fi Collective will point out that an online purchase can't be performed without a payment method. Based on the new information, you need to answer this question shown up here on the screen first, before visiting the draft diagram again. Without the payment method information, an online order can't be finished, and the online store can't bill its customer. In other words, each purchase record needs to be mapped to a corresponding payment method. As a result, a relationship between payment method and the purchase makes sense. So you can add a line between payment method and the purchase to make the 2 entities related to each other. This is how you start building relationships among entities. From here, the next step is to figure out the cardinality of each identified relationship. Cardinality describes the number of rows of one table that can be associated with a single row of another table. That's a big topic that we will cover in the next few videos. In this video, we defined ER diagram, covered 2 different types of diagram notations, and get started on building ER diagrams by connecting entities based on the requirement analysis. If you find this video helpful, give it a thumbs up, subscribe, and leave your questions in the comments. I would love to hear what's working for you and what needs to change. This video is based on the book Grokking Relational Database Design, which dives deep into database design using real-world examples to explain the concepts. You can find the link to the book in the first comment.